Thanks for coming to my talk. I am Matt Turner from London in the UK. I guess some of you are using the translation, so I'll try to go a little slow. I'm going to be talking about Istio. I'm going to be talking about running resilient workloads using Istio. So this is looking at a higher level at sort of applications and how you can use Istio to solve some of the problems you get with distributed applications, distributed microservices. I am CTO of a managed service provider called Native Wave. We're based a long way away in London, but we offer managed cloud native IT platforms. So if you want to know any more about that, then come and find me. Just by way of a quiz, who is using Kubernetes? Okay, most people at KubeCon. Who is using Istio in their production system? Okay, and everybody else is looked at Istio, interested in Istio. Okay, cool. Well, hopefully this is some useful information for you. So just a quick, I can't see the slides from there. A quick introduction about why we're looking at this. Think about what your business wants from the software you write. Think about the value you're delivering to users. What is the value to the users and therefore the value to the business of what you're building? Well, yes, you want your software to be good, you want it to be high quality, you want it to sell for a lot of money. That is your top line, right? You want lots of income. You want it to run as cheaply as possible. That's the bottom line. So you want to keep your expenses down. Kubernetes helps you with bin packing, maximizing utilization of your cloud resources. But also, what is important to a business is the time to market, so at the speed of experimentation and iteration. So how fast you can develop a new feature, get it out to a user, test it, find out whether it's what the user wants, and then use that to influence your next sprint or whatever, right? And get useful feedback from your actual users on your product. And this reduces the risk of building software. This reduces the risk of writing code for 2 years in isolation and then releasing it and finding out that it's not what anybody wanted and you can't sell it. So this is really important. And there's been a lot of work in software in the last 20 years maybe to get to that point. So we had Scrum, which says don't plan more than 2 weeks in advance because you don't have the evidence. And we also changed software engineering. So we took the monolithic applications that we had and we broke them apart, right? So this is a rock that is cracked. For anybody who doesn't speak English or like Latin, monolith means single rock, big rock. So we took them, this is why the picture, it's a bad joke. We took the big rock and we made it into lots of little rocks. So we have microservices. And that means that we can develop those in parallel. The code bases are smaller, they are easier to edit, and we can release the software separately, right? So if I want to make change to one part of my application, I make a change to that microservice and I can release it and I don't have to wait for everybody else. So I get my feedback really fast. And that's why we decided to write microservices, one of the reasons. But there is a joke, now that we've broken the monolith, how do we know that we don't just have a distributed monolith? So the joke says, microservices? No. What we've got is a completely different pattern. We have a distributed monolith. So I've taken all the code that I had before, I've separated my concerns. I'm a good software engineer. I've got dependency injection, and I've separated my code into different Java namespaces behind nice, strong interfaces, and they call each other, right? We knew how to write software in the 80s. It wasn't, nothing is new. But now with microservices, I split that, I put them all in a different pod, and I run them on Kubernetes. So we have the same code, and now it's spread out. The problem is, what used to be a function call between namespace A and namespace C that could never fail is now a call over a network. So there's a whole load of ways it could go wrong. The network could be on fire. The computer that pod C is running on could be on fire. The data center could be on fire. So we have all of the same problems as before, all of the bugs in this code, and there are always bugs. and a whole load of new failure modes which we didn't have before. So if my microservices look like this, one front end calls some back ends that all depend on each other, then if one goes wrong, I can start to get these cascading failures if I'm not careful. This is very complicated. This is an emergent property of this system, right? So one service fails, nothing else can reach it. Some of those don't handle that error and they fail. Some of them block while they're waiting and they sit there forever, and I get all these kind of cascading failure modes that I didn't have before. So this is a distributed monolith. This is a monolith where I've just thrown it into different pods, scaled it up, but not really thought about what that means for the quality of my system. So we have a way of solving this, and most of you know what Istio is, so I won't spend long on that. But one of the ways we can solve this is with a service mesh. So the service mesh comes along and puts a proxy. I will be demonstrating Istio, and Istio uses the Envoy proxy. This is the Envoy logo, but this applies to all service meshes. We put a proxy alongside each one of these applications, and that handles the network traffic for us. So, a call from pod A to pod B. Now, if pod B is down, then the Envoy next to pod A can say, okay, I will find another instance of pod B, and I have buffered your request, and I will retry it, and I will get you the answer as soon as I get a correct one. And if not, I will throw a circuit breaker and I will return you the last answer that we got, or a default answer, or something like that. So service A can have the business logic it had before, and it doesn't have to worry about the new network environment that it is in, because that is complicated and it can fail. So to make a service mesh useful, we need a way to configure all of these proxies. They need to do different things. We will see this, but maybe when service A calls service C, that is a database transaction, and it's not safe to retry that. If service C is your actual bank account, the ledger, then if service A, you need to make sure that service A doesn't try to call it more than once, because you don't know whether the failure that you got happened before or after the actual bank account records were updated, right? Whereas if you're just fetching a cat GIF, if you got 99% of the way through and it failed, then you can just try again, and hopefully next time you'll get 100%. There's no side effect to that. That operation is called idempotent. So each of these proxies, and you might want a different timeout for different routes. You might want all kinds of different configuration. So each of these proxies gives you all of these features, but they need to be, the point of this talk is that they all need to be told what to do, and that depends on your application. So a service mesh comes with a control plane. Istio has a control plane and a CLI, Istio CTL, which you use to talk to it. And the control plane, you give the control plane a simple definition, quite simple definition of how you want the service mesh to act, and then the control plane will configure all of those proxies for you. This is another bad joke. I would say it is not all plain sailing. If you think everybody knows about Kubernetes here, if you think about how you use Kubernetes, when you first start, you just make a deployment, right, and a service. 2 resources, and one says, here is the workloads I would like you to run, here is the code to execute, and then the service says, and here is how you expose it over the network. So all of these pods are listening on port 80, and I would like you to tell AWS to make a load balancer so that I can get to all of them, right? Simple, Kubernetes 101, it's how we start using it, and it works. But if you want to make that application resilient, if you want to use Kubernetes in production, then you're going to need ingress, right? Because your product owner probably wants several services on a path-based route behind the same IP. You want a horizontal pod autoscaler. That gives you resilience against having lots of users. Having lots of users is a good thing, but if you only have one pod and lots of users, that pod will crash. So you need to be resilient against that. You need to tell Kubernetes how to scale your application. You need to set requested limits. You need to set readiness and liveness probes. You also probably need some config maps and some secrets and some upgrade strategies. The translators could ignore this. I have a joke like affinity, anti-affinity, pod disruption budget, pod security policy, network policy, pod preset, service account and RBAC, limit range, cluster autoscaler. There's probably more. my point, apologies to the translator, my point is that it's not as simple as just telling Kubernetes to run your workload. You need to configure all of these extra things to get the most out of it. So Kubernetes can do some stuff out of the box. It will have if your application actually crashes, if it just seg faults, then Kubernetes knows that's bad and it will restart it. But there's lots of other failure modes, like it just, it's still listening on the port, but it just never replies because maybe it's deadlocked. Kubernetes doesn't know how to detect that in the general case. So you have to write a health check, a liveness probe that hits the HTTP port and tries to get a response. And only by doing that can you tell Kubernetes that, this service is a network daemon that is meant to be replying to HTTP requests, and if it doesn't do that, then it's broken. So configuring Kubernetes is about describing your application to Kubernetes, saying, hey, we have this Unix process, it's a black box to you, but I'm going to tell you that it can only do 1,000 requests per second, and when it starts doing that, when it gets to 1001, you need to make a new instance. It's listening on TCP, so if you send a valid TCP request and you do not get a valid TCP response, or you get a HTTP response that says 500 in it, then it's broken. So it's about a lot of the Kubernetes stuff is about describing your application above and beyond that lowest common denominator of it's a Unix process and it should not crash. So as I say, we can use Istio when we have one of these distributed systems, and we need to help out with some of these new distributed systems failure cases. So the tagline says that Istio is an open platform to connect, to secure, to control, and to observe microservices. And all of these words are actually quite important, and I'll go through them in this talk. But basically, what this talk is about is that you need to do the same with Istio. You need to describe your application to it. You need to tell it what to do to help you the most so that your application can be properly resilient. I'm not going to set my demo up. I can't get my VPN to work. I have a recording, so we'll skip that. I just can't. So the observability part. This is going to be really awkward because I can't see the screen. So Istio can do all of this stuff. And I guess by default, it will connect your applications. If you install Istio and then you deploy your application, the sidecar is there and it intercepts all of the traffic and it moves the traffic from one place to another. So pod A to pod B involves the traffic going through 2 copies of Envoy. And like Kubernetes, it does lowest common denominator stuff. If you're trying to talk to service B, then it's going to pick the traffic up and it's going to move it to service B. Of course it is. But it won't retry it by default, because in the general case, that's not the right thing to do. In the general case, that's not safe, because it might not be an idempotent operation. You also can't necessarily, you might think you want to secure all the traffic between pods, but in the general case, you actually can't do that because it interacts weirdly with some other systems. And what does control mean? If one pod breaks, do I want to route traffic around it? Do I want to return a default? Do I want to just sit there and try again? All of these things need to be described to Istio. So I'm going to take you through some of the Istio configuration that you should use to get the most out of Istio and to get the most benefits to make your application reliable. So the first is observability. Observability is 3 main parts. It's metrics about the traffic. It's a service graph of the traffic, which pod talks to which. When you had a monolith, you can just attach a debugger. If there's a problem in namespace A, you attach a debugger and you step through and you find out that it's calling some code in namespace C, and that's where the underlying core problem is, the root cause. With a microservice, you can't do that. Service A is returning 500s, but you don't know why. And it may be because it's calling service C, but you don't even know it's doing that. So the service graph will tell you that. And then distributed tracing. I'm sure everybody knows Jaeger, Zipkin, Lightstep stuff. That's another very useful thing. The green tick is me saying that I think you should do these things all the time, right? These are safe and great, and you should always do them. So I have a demo. I hope you can read it because I can't make the terminal any bigger now. Okay, so I have some scripts to do the demo because I don't want to type. I already have a GKE cluster to show you this in because they take a long time to spin up. I recorded this over the VPN in the hotel, so the latency it gives me time to talk. It was deliberate, I promise. So we have a one-node Kubernetes cluster. Okay, and I have downloaded the latest Istio 1.02, and I have already downloaded Helm. You need Helm to install Istio. So, okay, this is me installing Istio into the cluster. It's normally quite fast, but the latency was bad. What's interesting is that this installs Istio. So Istio is some pods, right? Istio is some workloads. The Istio control plane is code that runs. But also, when you install Istio, it installs a lot of configuration. So all of this is the default configuration for Istio. It's not baked into the code. It's supplied in Kubernetes config maps. You know, like I said at the start, that is something you should do with Kubernetes. That is a best practice, is to have your configuration managed separately and provided through config maps. And that's exactly what Istio does. So this is kind of what Istio does out of the box. You can go and read all of these files. They're actually quite interesting. So out of the box, it does a lot of stuff for you, and observability is one of those things which I'll show you. It doesn't do everything, though. I think my cluster was in San Francisco as well, so this is pretty slow. Fast forward, right? It's nearly there. It's nearly there. If I was hacking, it would look really good, but I'm just standing here. Come on, Istio. You see, Istio knows how to use Kubernetes. Istio is installing horizontal pod autoscalers to describe Istio control plane to Kubernetes. So Kubernetes knows how to keep Istio running so that Istio can keep your application running. Must be done. It's got a lot of features. Oh man. It's alphabetical order, right? T? No, it's not. There we go. There we go. Right. So Istio is installed. I'd forgotten I'd recorded that. Now I'm going to deploy the bookinfo application. It's a sample microservices application. If you've looked at Istio or the documentation, you've probably seen it. I didn't write my own because I think that actually does confuse things. I'm not lazy. I think actually if it's bookinfo, you know what bookinfo is, so you don't have to think about bookinfo, I hope. So we deploy bookinfo. I think the lag was really bad here. And we'll start to see the bookinfo pods coming up. Super bad. I should fast forward. Show me some pods. There's something I want to take. Right. So you can see with all the pods coming up, this is standard Kubernetes YAML file. It only describes. It only talks about one container in the pod, but the pod can have more than one container. And we know that what Istio does is put that sidecar next to our application. So this here, 0 of 2, means that we're still waiting for this to start, but we're waiting for 2 containers to start. And one is the application, which is in the pod spec, in the pod.yaml, and the second one is the Envoy sidecar that we as a user do not tell Kubernetes about. When we describe our application to Kubernetes, we don't describe the sidecar because it's not part of the application. Istio injects that. Istio does that automatically. So as I say, out of the box, by default, all traffic goes through that sidecar because the default Istio configuration will inject it. Is that all of them? Product page, go. Okay. So yeah, 6 pods with our application, all with a sidecar. This script just finds the public IP address of the ingress point. It's quite boring, but it's necessary. And then we can go to that URL. So this is bookinfo, if everybody knows. Tells a website telling you about one book. Book details are on the left. Fake reviews of the book are on the right. Some of the reviews we keep hitting refresh. Some of the reviews have this star rating and some do not, because we are A/B testing 3 different versions of bookinfo. One shows no stars, one shows them in black, and one shows them in red. So we just hit that and refreshed it a whole bunch of times. So we generated traffic, right? All of the microservices worked together and gave us that bookinfo page. I know it's ugly, but like 6 microservices work to give you that page. And we just did it a bunch of times. So what I'm doing now is I'm just setting up a port forward. It's boring plumbing, but I'm setting up a port forward to a part of Istio called Kiali. And that is an observability dashboard. So one of the things we get for free with Istio, and one of the things that's very useful in running a resilient application, is observability and the ability to get deep insights into your application and how it's running. We have to log into Kiali. And now we've done that, we can see that there is a Kubernetes namespace default with 4 things running in it. Right, 6 pods, but 3 of them with the different versions of the star rating, so 4 moral applications. And completely for free, we have not described this, right? We write a load of YAML that describes our application to Kubernetes, and we'll soon be describing it to Istio. We have not described this graph. This is made empirically, a posteriori. I don't know what's easy to translate. This is made from the traffic that is being sent through the cluster. It's amazing. This is a simple application, but you see the graph of all the microservices Netflix has, right? It's huge. It's thousands. So you'd be amazed how many people don't know this about their own set of microservices. So first step to getting the most out of a system and making it the highest quality is to understand it. So this is a really, really powerful tool to understand it, which is why I've put it in here. And you can get a bunch of different views from this thing. Running a little bit short on time, so I will skip through this. I think the next thing you want to do to get your resiliency is to take advantage of the traffic routing in Istio. This happens at layer 7, so this understands the HTTP protocol and can do more advanced things because it understands more about the intent of the transaction because it can understand the HTTP header. So we can tell Istio about the different versions. You see there were 3 versions of the star rating microservice. Kubernetes doesn't know anything about that. They all share the same labels, so it just round robins traffic between them. As far as it's concerned, they might as well be the same thing. We know they're 3 different versions, and we know we should be treating them differently. So we can tell Istio about that. We can then start routing the traffic so we can pin it all. The demo will show you that. First of all, we will say the A/B test is not ready yet. You know, we have deployed version 2 and version 3, but they're only internal, so we'll send all the traffic to version 1, and then we can start shifting it to version 2 and version 3, so an A/B test, basically. You can do canaries. That's a popular word, but really that's just an A/B test with a much smaller sample, as far as I'm concerned. And there's other things Istio can do for you because we have this powerful Envoy proxy in our network. You can do really clever things, like if if one application is serving XML, another application wants to consume JSON, you don't have to translate that in either application. You can just tell Envoy to do it. The network will just transparently do that. So if you can describe to Istio, hey, I just deployed an application, but it's legacy. It's some third-party piece of software I bought, and it only talks XML. I want you to make it look like it talks JSON to all of my other services, right? And that avoids you writing another little microservice that tries to do that translation and sticking it in the middle, because you'll probably get it wrong. There's bugs in all code. Like, why would you write that when it already exists? So that's another step to making your application more resilient. I think the demo for this is quite good, so I'll do it quickly. Super hard. Super hard. Okay, so we do the setup. I won't bore you with how the YAML files work. Oh, I think I missed it. Where is it? So the first thing we do, we keep hitting refresh. This is that traffic pinning. So a normal user now just gets version 1, right, which didn't have any star ratings. Star rating is a new feature that we want to test. We want to test it real fast. We want to get that feedback, but we still want control, or we still want to send most users to a code path that we know works, right? Most users don't want to crash. It should be resilient. And then the new code path is maybe untested, but we need to see the feature. So we can tell Istio to do, because we understand HTTP, we're going to do something more clever than Kubernetes can do. We're going to say that if you're logged in as the user JSON, I think couldn't type. If you're logged in as the user JSON, then however many times you hit refresh, you always get version 2. You always see those star ratings. But that's not random A/B test. That says that, JSON works for us. He wants early access to V2. He's going to hammer that before we let it loose to the users. And JSON will get V2. Everybody else will get V1. But that's based on looking at the HTTP header that says who is logged in. Right, so you can do much more clever things like that. You can send a new version just to the users in France. You can send a new version just to the users who are using alpha browsers, because you think they're the kind of people who like to take risks, right? And will maybe blame their browser if your website goes wrong. I mean, that's great. I think we don't have time for the next demo, I don't think. But that's showing you RBAC. So we can get Istio to add actual resiliency features. So there's a few things we might want. We might want a timeout. Say one application is being slow. This is another cascading failure, right? Everything blocks, waiting for it. Obviously, you can write asynchronous code, but normally everything will block, waiting for it. So we can tell Istio that if a backend doesn't reply in 2 seconds, it should just send a 500 as if the other end had done that, right? Because the other service is in a deadlock, and it's just going to sit there forever. So we can tell Istio to just give up on your behalf, right? This is now code that you don't have to write in your microservices, because it wasn't there, because remember we had that monolith, and a call from namespace A to namespace C could never fail. It would probably never wait that long. Either the whole thing has crashed or it hasn't. Now we've introduced this network that might be super slow and super congested. It might be on the other side of the world. If service A doesn't get the service level, the quality it needs, from service B, then we just get Istio to time it out, and we don't have to add that to our application. We can also have circuit breakers, which are a more brutal version of the same thing, and say that if a service fails 3 times within a certain window, we just decide that it's dead. We just never talk to it again. That makes things resilient. If a service is being flaky, maybe the underlying hardware is failing, then we can just do that. As I said at the start, we can get Istio to do retries for us, and that's very configurable. So we can tell it only certain things should be retried. We can tell it how often, how fast to try. We can rate limit things. This is really important for making your system resilient. No software is free of bugs, and no software is infinitely scalable. So you should test your software. You should know how many requests a second your microservice can cope with. And still meet your SLO, so still say return 99% of answers within 100 milliseconds or whatever is acceptable, and then you find out that limit for this release is 1,200 RPS, and then you set a rate limit. You say, hey, Istio, don't ever let more than 1,200 RPS hit this. So that, again, is another key to resiliency. And you would then describe that to Kubernetes as well, so that maybe when you got to 1,000, you would start to spin up more copies of the pod in anticipation. A counterintuitive thing you can do to increase resiliency is actually to introduce faults. So Istio can introduce delays, and it can introduce faults, like HTTP 500s. But this is chaos testing. If anybody's heard of Chaos Cube or Chaos Monkey, these things come along and they kill AWS instances, right? And they kill pods at random, and they make sure that you run a test while that is happening, and then you know that your application can cope with it and is resilient to it, right? Resilient to compute failing. Now we have distributed our application and it's running, all of these calls are across a network. We have another failure mode. The network might fail. So what we do is in staging, certainly, we get Istio to pretend that network is slow, or to pretend that network is unreliable. And then we know that we can test whether our application still copes with that, either through code in the application or through other things like retries and timeouts that we've configured Istio to do. So that may seem counterintuitive. There is an argument that you should do this in prod. You should test in prod. See Charity Major's talks. There is an argument you should have this running all the time. But definitely in your staging environment, where you're also using, doing soak tests and using load generators and all that kind of stuff, you should have this kind of chaos running. And as I say, it's counterintuitive, but it does increase your resiliency, and it's a service that Istio can offer. Security, this is your resiliency against being attacked. If you misconfigure things, the internal part of your application, maybe the actual bank account records part, would only have been called by other things, would not have had an API directly on it. It was only accessed through other parts of the monolith that are maybe doing authentication. That's not good enough now, because this thing will have to listen on an API of its own. So if somebody can break into any pod, any other part of your infrastructure, they now have access to that in a way that they didn't before. So you want mutual TLS for encryption. You want strong authentication to know which services you're talking to. And you can then turn on service authorization, which says that if I am the bank account records, only the UI component can talk to me, because it displays balances, and that's fine. But the microservice I've got that onboards new users never needs to see anybody's bank account records. So just ban it from talking to me at all, because if it's ever trying, then that's a mistake. It's an error in the code, or that pod has been hacked. So we can do that when we have TLS in place. That was what the last demo was, but I've kind of run out of time. And then other things that you just don't want to re-implement, or that you don't want to bother using a library for in every application. Things like injecting cause headers, any other kind of security middleware, JWT validation, XXS mitigation, any kind of web application firewall function. You can have Istio do. You just describe your application. You say, you can see that this thing is listening on port 80. Yes, it's talking the HTTP protocol, and this isn't a REST API. It's actually talking that to a browser. So I want you to do all of the standard stuff like injection attack detection and cause header injection. So this just means that you don't have to download a library into your application to do that, hook it into your build system, check that it's working properly, upgrade it every time there's a patch. You just let the network do that. And I say all of those things about it's complicated to have your app do it. Of course, a lot of people just don't do it at all because it's too hard. But with one YAML file, now Istio will do that for you. So Istio has a lot of power. I think the demos that you see are normally around the clever routing that you can do, and it's great. It's great to have those features. but the network is now a really important part of your application. It has a really important effect on how all of the different microservices work together as one unit, and that one unit has to work as one thing so that your users have a good experience, right? So in the same way that you need to tell Kubernetes a lot more than just please run this pod, you need to tell Istio a lot more than please just move my traffic, because the network was doing that for me. And if it just moves the traffic, you get observability for free, which is a really good step towards a resilient system, because if you can observe it, you can control it and understand it, but also you can configure Istio to do the retries and the timeouts and everything else that we've seen. Some of the things I went quite fast. Some of the items had like a yellow question mark, which meant sometimes you need this, so a retry is not always safe. And some things had a red cross, which actually means you really only want to do this in an emergency. So you can do things like log all of the traffic. There are privacy implications to that, security implications to that. But if something is going really wrong, you can get Istio to keep the service up, keep sending traffic to the production instance, but also send a copy of that traffic to your laptop so you can read it and try to work out what's going on. So there's a few options that you would leave turned off, but you have a YAML file ready to go and turn them on. I think I'm just about on time. So that's what I wanted to say. Thank you very much. Happy to take any questions. Sure. I'll repeat it, yeah.
So I don't see much of talks about Istio or linkage around like virtual kubelet or ACI or like serverless sites, right? So I am hoping that it will be same and it won't make much of a difference. But as you said, like non-network is a very big part, big component of your application. So do we really have use cases around this? Are we even talking about it, or is it just too early to talk about that?
That's a really good question. So the question was, what if you're not running in Kubernetes? Istio, by the way, runs on like console and Mesos, the older stuff. But if you're running in serverless, ACI, virtual kubelet, then the newer systems, what do we do? I guess I think you do want the same features, and the same technology is actually giving you that. So Knative Serve is a serverless framework, right? It can scale to 0 and all of that stuff. It's based on Istio. So two things that are on Knative Serve, even though they're serverless, you don't have to deal with the deployments or the rolling upgrades because it's a serverless framework. The traffic between them is still going through Istio. Knative Serve installs Istio and you just don't see it. So we're already like one layer of abstraction higher than this. The other thing is that Envoy, the proxy used by Istio, just last week released like a library version for iOS and Android. So now, even if everything is hidden behind a virtual kubelet and you just hit an you just deploy a blob of code to run.sh or Heroku or something, and you can't take control of it, you can at least have the client do timeouts and retries. Because you can now download Envoy as a library and you can link it against your Android application. And even if the server as a whole just fails and says 500, you can get the Android application to retry and then to time it out. Because Envoy is now being released as a library. So does that help? It's more about, it's about what you have to do at the end of the day is get those envoys in there next to all of the components in your system. So I guess if you're using a virtual kubelet, I don't know how you do. If you're using Fargate virtual kubelet, I don't know how you do that because they take care of the compute fabric and you don't have enough control to inject Envoy. But a surprising amount of the systems that do present that higher level of abstraction, like Knative Serve, actually have this stuff built in and will do it for you. And in the worst case, you just have the client do it. I hope that helps. Anything else? Cool. Let's all go get some coffee. Thank you again.